Hi, welcome to CloudXLab.
Sandeep sir, should we start?
Yes, please.
A very good afternoon to everyone present here. I, Yash Amin, Event Manager of IEEE TCET 2021-22, would like to welcome you all to this webinar on the topic Cloud Computing and AI. As we all know that due to the recent COVID-19 pandemic, businesses have started to adopt AI more than ever as it helps to get useful insights in businesses and boost productivity of businesses by automating the routine activities. Cloud computing improves these AI solutions by providing improved data management and secure storage services at a low cost. These topics will be discussed in detail by our esteemed speaker for today, Mr. Sandeep Giri, who is an alumnus of IIT Roorkee. He has a substantial experience of over 16 years in the field of software development and big data and has worked for companies like Amazon. Along with that, he is also the founder of two companies, which are CloudXLab and DejaVu.ai. We welcome you, sir, to this event and hope to learn lots from your extensive knowledge about the topic. Over to you, sir.
Wonderful, wonderful. Thank you, Yash, and thank you, TCEC, and yeah, TCET. All right. So wonderful to have all of you in this discussion. I'm really glad to have such a great audience right now. So we have close to 61 participants right now. So what I would like to do is I would like to give you a overview on the AI and the practical aspects of it. Like, what are the parts that you need to learn? What are the parts that you need to learn? And what are the parts that, I mean, how does AI on cloud or AI in production looks like? I'm going to give you a proper overview, something that we have done at Amazon, something that's happening in industry and in cutting edge technologies companies. So you will be able to relate to it. All right. And you will be able to learn something that is really useful. Instead of keeping this discussion to be one-way communication, I would urge all of you to start asking questions using the Q&A window as we go ahead. What I'll do is I'll pick the question or I'll ask one of the organizers to pick the question and ask me to make it more, more interactive. Otherwise, I tend to get awkwardly boring for some people, but trust me, I'll try my best not to get boring. Okay, so we will try to keep this session in a way that it is useful. And in these 2 hours, in the next 2 hours, you will walk out with something that you before never knew. All right, this is going to help you. This is going to help you in your career. This is going to help you, improving your understanding of the subject. And it is important to know everything. Okay, even if you are not related to the computer science, even if you're not related to machine learning, you're not related to cloud, it is important to know about it so that you can take a call whether to get into it or not. All right, before you wouldn't know that ice cream was a good thing before eating an ice cream, right? So similarly, you should taste it. You should taste the understanding of the AI, understanding of the cloud, and then take a call. All right, so feel free to ask lots and lots of questions using the Q&A window, and I'll make sure that I'll be able to answer. So we have close to quarter to 2 hours, like 1 hour and 45 minutes. And I'm going to walk you through the various aspects. All right. So the this is what we are going to talk about. All right. So we are going to talk about about CloudXLab, what is AI, what is machine learning, understanding machine learning process, understanding cloud computing, and so on. The most important part in this is I'm going to walk you through the six steps to take an application to the production, and with the real hands-on ideas. All right, so that's something that is going to help all of you. I think you got my introduction already. So I have been doing engineering since 2002. How many of you know? You can use the chat to answer. Okay, how many of you know what exactly is DSHA? Anybody knows DSHA? No? I joined DSHA in 2002 after passing out from college. No? All right. You can use the chat window to answer. Q&A to ask questions. All right. So, all right. I think most of you just signed in to ensure that you get certificate, is it? And all right. So yes. So there's this company called, okay. All right. There's a company called DSHA, and DSHA, we were doing lots of computing, and we had probably the largest cloud before Amazon. For those who are wondering, is it popular, right? So Jeff Bezos, the founder of Amazon, actually was working at DSHA. So those are the two things common between me and Jeff Bezos. And after that, I joined InMobi. After the show, I founded a company in Hyderabad, and then I joined InMobi, where I was building large-scale systems. Large scale is in 200 terabyte kind of thing. And at Amazon, also the detail page that you use on your phone, from where do you do the buy now? The mobile version, one of the mobile variation is mine. I think that has gone to production. If when you click on buy now, if it vibrates a little, you probably are using my variation. All right, so that's what I did at Amazon, and then we started CloudXLab. About CloudXLab, I'd like to give you a bit of overview. So at CloudXLab, we are making learning fun and for life. The way we are doing is by the way of videos. We have video content, we have quizzes, exercises, hands-on. Now, the most important thing that we have done, as opposed to anybody in the industry, is created a lab on the cloud so that you can do the hands-on learning on any topic related to AI, big data, DevOps, and so on. So we created lots of guided projects, and we have a case study based learning environment. And all of these are based on our experiences in the real industry. Because when I was at Amazon, we were finding very difficult to get engineers who were trained on practical application. And that's why I started CloudXLab. And what we offer is a great online lab, an automated assessment engine, and so on. So you can basically just sign up for CloudXLab and start using technologies and start learning lots of ideas. All right. So the idea is that everything is available on the cloud. It's zero installation. You don't have to worry about anything. Just sign up and you'll get the login password and start accessing the cloud and start learning and experimenting with things. So that is how it is. And it is the real experience, because when we join, let's say if you join Amazon or any other top company, you will get a cloud space where you will be responsible for deploying or building your application on the cloud instead of your desktop. So that's why learning on the cloud is the most important thing that happens at CloudXLab. We have all kinds of technology at CloudXLab. You can try them out. Now, this is something important at CloudXLab. So you can just log in at CloudXLab and click on, say, Linux tutorial. That's a free and foundational thing that anybody can sign up for. There, what you have is, on the left-hand side is a challenge, or you can say a small, tiny bit of exercise for you. And on the right-hand side, what you have is the lab on the cloud that contains the terminal, Linux terminal. And when you submit the answer after doing your job, doing the work, it'll give you the congratulatory message, and it'll give you the points. And that's how you continuously learn. This immediately checks your work and gives you rewards. Now, similarly, we have almost every technology notebook or environment, like we have Python, we have like most of the programming languages that you know can be made available on this site. So this is an example where you take here's a challenge, define height, weight, BMI, and once you do that on the right hand side and submit answer, you get congratulatory message, and and you get the points. So this is one of the very good ways of learning machine learning and AI or DevOps or any computing, because this is real hands-on. And on the right-hand side, what you see is not something an editor created by us. No, it is a Jupyter notebook. That is something that people use as of today in order to learn. So you can simply go to, say, CloudXLab, right? And you'll find lots of places to see. One is the news feed that you see. Other is, say, Explore courses. All right. And then you have these. But in this, if you go for guided projects, you'll find lots of guided projects, and you will automatically get certificate on that part. But you'll have to do it. It won't it won't happen like you will have to, right? You won't get the certificate for free. You'll have to actually work on these. Okay. And these are guided projects, and this is like full environment where you will find everything. Similarly, you can just go to my lab here, and then start experimenting with various technologies or SQL and so on. A easier way is just go to my courses. You will find like all kinds of courses for yourself. All right. So this is basically something that is there, right? And then from time to time, the various IITs are launching courses at CloudXLab, so you can attend to those courses as well. All right, so you can attend to those courses and you can join those courses. So there are quite a few things that you can learn with respect to the new age technology. The topic for today is AI is everywhere. Before going there, let me answer question by Rohit. Question from Rohit is, can you tell us what will be the best way to learn AI's basics and its important topics as an ENTC students? Like, how can we divide and manage about AI topics? Don't worry, I'm going to discuss this part towards the end again. All right. So in the meantime, take a look at a couple of courses at CloudXLab that will help you get an idea about the curriculum, and that will really get you started. But my suggestion would be that while you join the course or anything, do not miss doing the hands-on project. Hands-on project is something that matters a lot. Instead of only talking about what is AI, what is machine learning, you'll be able to build something real. All right, I'm going to walk you through those steps. All right, so wonderful question. Moving ahead. So as of today, AI is everywhere, right? Whether you talk about the self-driving car, or you can talk about the talking robots like Sophia, or you talk about building a Mars rover. So lots of parts of most of the engineering systems are designed using the machine learning today or AI today. And whether it's an understanding of the language and so on. So similarly, when we talk about the face recognition or facial recognition, there's a difference between the two. Facial recognition means a recognition of the emotions. All right. So what you have is the face recognition, also termed as computer vision. Computer vision is all about understanding the world by the way of visuals, right? So whether it's face recognition, whether it's facial recognition, or it's detecting objects in the real life and so on. So face recognition is another big era in which the computing has done way better job. So so there is a data set called there's a data set called ImageNet, and there used to be this competition for ImageNet whereby the computer is supposed to identify the objects, and computer is supposed to identify the objects, and in that the computer has been way more accurate than humans. Computer has been way more accurate than humans since 2016. Okay, since 2016 and 17. So right now, the total error that human does is around 5.3, and the computer was able to go below that in 2017. 5.3 per percent of the images that are shown to people. All right. So similarly, there has been a big breakthrough in voice recognition or speech synthesis. And all of these, the credit goes to the deep neural network or the new age machine learning. And similarly, playing games, AlphaGo played games against the world champion and won against it. And so, oh, I'm so sorry. All right. I'm so sorry. I have been under the impression that my screen is being shared since the beginning. Thank you for letting us know. Okay, so I have been talking a lot of things. Okay, so this is me. And okay, so this is what I talked about when I said that we are making learning fun at CloudXLab, and we have gamified environment, and we have all these technologies installed. This is the environment I was talking about when we okay. And yeah, so this is the environment that I was talking about. You can take a look at it. So on the left-hand side, you have the problem statement. On the right-hand side is the lab. And when you submit the answer, it checks your work and quickly gives you rewards or gives you suggestion what to do. Similarly, this part, okay. So I talked about the AI is everywhere, and AI is also in voice recognition. And similarly, playing games, and similarly, almost every industry as of today is utilizing AI. And lots of people ask me that, can you share the use cases on this industry, that industry, and so on. So here is my suggestion to all of you. Okay, just a second, I got some messages. Okay, so the almost every industry is going to embrace AI or machine learning, because if you look at all of the engineering fields, whether it's agriculture, medical, or manufacturing, tourism, everything revolves around predicting something. Therefore, any technology which aids in prediction is something that's going to be the heart of almost every industry going forward, whether it's biotechnology or anything else. It'll become as common, or as, you know, it'll become the underlying engine for almost everything. Just like calculations impacted every industry, similarly, the neural network or these new tools will impact almost every industry. And the computing also is a big example. So maths, computing, and machine learning are going to be part of every industry, every sciences, and so on. Okay, so and therefore this is a good reason to understand what we're talking about. So when we say AI, there's this term called, very confusing term called AI, machine learning, and we use them interchangeably. So I like to express this. AI is something that we want to achieve, meaning we want to achieve intelligence. Intelligence meaning that something that is able to predict something, right? We want to build a machine which is intelligent enough to be able to predict outcome or predict the movement and so on. So AI is essentially, creating intelligence. Okay, this intelligence, could be this intelligence could be designed using multiple systems. It could be based on rule-based systems, as in we coded the machine. Like, for example, if you take Alexa, the Amazon Alexa, it is essentially designed using rule-based programming and other systems. So the AI is essentially designed using multiple components such as hardware that could be robots, IoTs, and sensors or motors. And with respect to the software, as in some of the rules or the logic could be we coded it, and some of the logic could be something that machine figured it out by the way of using data. From the data, it inferred the rules, and we call that machine learning. One of the neat algorithms, or you can say a bunch of algorithms that rely upon deep neural networks or complex systems, is called deep learning. Deep learning is essentially machine learning using deep neural networks. Okay, that's one of the techniques of doing prediction. So what exactly is machine learning? Machine learning is the field of study that gives the power to the computers to be able to infer the rules from the data without explicitly programmed. Okay, just like the way you guys are learning is by the way of observing things and taking look at the outcomes. Similarly, the computers also learn using the data. All right, and that's exactly what is machine learning. I want to take you through a very interesting example, and this is something that connects me really well. So how many of you have played Mario? Feel free to chat using the, okay, please raise your hand. I think raising hand is also good. Okay, raise your hand. How many of you have played Mario? I know that it's a little older game now. Nowadays, you play something more fun. Okay, but still, there is a charm to it. Wonderful. Wonderful. All right. So do you think the computer can infer, computer can also learn to play Mario just like you did? All right. So this guy, Tom Seven, he did a bit of automation. And what he did was he loaded the Mario game into a simulator. And if you want to play the Mario game now, you can load it in the simulator and you can play. Okay. And you can basically you can play the Mario game inside the simulator. So what he did was he hooked the simulator to the software program, and the software program was basically playing
Sir, you're on mute.
You created a business.
And I've clicked on unmute. I think probably you started recording the moment you started recording, it did that. All right. So wonderful, wonderful. I hope my voice is coming through fine, everyone. Please feel free to reply to chat. Are you able to hear me, everyone? Reply through chat. Just to wake you up, those who are in afternoon sleep mode. All right. Please reply on the chat. Are you able to reply? Do you see the chat thing? No? Hello.
So
Yeah.
we're getting replies in chat.
Wonderful, wonderful, wonderful. So people are awake, they have not slept off. Okay, so great, great. Let me, okay, I'm not able to find that to be, right?
Now?
You, okay, next one is coming up.
Create videos for your business.
Okay.
Hey.
Yes. So this guy, so it's a very interesting case study, and I want to just take you to the point where this is something that gives a good idea to people about how the so this is like the beginning of it. Okay.
Super Mario Brothers. Pretty good at
Just a moment. I'll move on to a point. Good point. Okay.
still pressing buttons like crazy and jumping backwards for some reason.
Yes. So this is something like, you know, the beginning of it.
Approach, which works a little bit better. Mario's looking a few frames into the future.
All right, let me just turn on the mute. Okay, so you can take a look at. All right, this is what I wanted to show you. That in the beginning, it's like really lame. Just a moment. Yes. So this is the point. Okay. I hope my you can see that this is the beginning of it. So in the beginning, the computer just kept on going crazy, kept on pressing the button like crazy, and it did not go anywhere. All right. And after a couple of more plays, the computer started learning by more data, more plays. It kept on gathering the data by itself and kept on trying out all possibilities. Now you can see that nobody has taught it what it means by jumping. Nobody has taught it by what it means by moving and what it means by gravity. Hello, everyone. There is some crazy thing happening right now. I just got disconnected from it, and everything seems to be okay. Yes. Hey guys, are you able to hear me? I don't know what happened. This is very strange for me. Okay, so are you able to hear me? Is it going okay?
Yes, sir, you're audible.
Okay, something crazy is happening right now. It has never happened before. Probably Zoom is getting just too much network or something. I just got disconnected and then again, I got muted and screen. So, okay, my entire flow is broken badly. So the thing that I'm trying to show you is that the computer kept on looking at the screen and kept on pressing the buttons. And just to figure out how to play this game and how to maximize the score. Okay, nobody taught it exactly. Nobody taught it exactly how to play. We just hooked it to the computer, to the simulator, and let it play by itself. And after a while, after some time, it has started to become really, really good. So what you're going to see is something just amazing. So here, I don't know why he did that, but after a while, it started to play so well. It started to play so well that it's just amazing, right? It's just amazing. I'm going to show you something, right? So here it's going to do something really, really smart. Okay, except for this one. Okay. So the computer started to learn so perfectly, and you will see something amazing that happened. Okay. So you're going to see this. What was that? This part here. So the moment the Goomba is falling on it, it starts moving downwards. It starts moving downwards. You see that? It starts moving downwards here. And this is exactly how he gets the point. Have you seen this before, this kind of thing? Okay. So it figured out a bug in the game. It figured out a bug in the game so that it can score even when Goomba is falling on it. And that's something amazing. It's just amazing. Wow. Okay. So essentially, the computer learned to program, learn to play this game by itself. And in a sense, it learned to create its own rules. It understood what it means by jumping, what it means by collision, what it means by, right? It even was able to trick the collision. Okay, so this is something just amazing that it was able to play other games. All right, so you can take a look at this one and let me just move ahead. Okay, so quick question to all, that if you have to make this program learn to play Pac-Man, will you have to write rules as per the game? That's option 1. Or option 2, just hook it to a new game and let it play for a while. Yes? What do you think? If this needs to learn to play Pac-Man instead of Mario, do we need to write new rules as per the game, or just hook it to the new game and let it play for a while? Anyone? Option 2. That's right. That's right. So the answer is option 2, because you don't need to write the rules per game. Okay, you don't need to teach it that if Goomba comes to you, you have to hit it and so on. It'll figure out by itself. Okay, and that's the beauty about it, because if you remember, the way you learned Mario was not by somebody teaching you, somebody teaching each step of it. You figured it out by yourself. There were only these few scenarios where you may not have been able to cross it, and somebody else's ideas would have worked better. But mostly the learning is automatic. All right. So imagine doing the same for the life, gathering data and automatically solving problem. You can think of yourself as Mario in this whole new world where you have to predict your next steps in order to gain better health and improve the happiness. All right. So the question is, how do we generally solve most of the new age problems? By the way of gathering data and doing intelligence on it. In case of Mario, it was able to gather data by the way of automatically playing the game over and over. And the intelligence is something that we have to provide. Okay, so to gather the data, we basically have to collect, clean, and process. For collecting the data, you have IoT solutions, and you have in today's time, the connectivity has gone really, really good. As of today, the Wi-Fi, 4G, and NFC, and GPS, these are the few examples other than Bluetooth and so many other ways of network. So while on one hand, the devices have become cheaper, faster, and smaller, on the other hand, the connectivity has improved, and that essentially has aided collecting of the data. Now, cleaning of the data, since cleaning the data is humongous, in my case of InMobi and elsewhere, the data was around 200 terabytes data. And processing or cleaning, like cleaning or processing, what does it mean? It means like changing one format to another or removing unnecessary data from the files. Okay, that's not possible using one single computer because the hard disk read speeds is one of the bottleneck and the other hardware is a bottleneck. In those cases, what we do is we group the computers together in a network and make them interact with each other, and so that they can achieve a common goal, such as cleaning the data or processing the data. And this is called distributed computing. If you want to do distributed computing, you will go with Hadoop, Spark, and other frameworks. Then there is a term that I'll be using in future is called parallel computing. Parallel computing essentially has lots of processors, and there is a common shared memory, and you interact with the memory, and these processors interact with the memory in order to do the predictions and so on. All right. So basically what I'm talking about is that for doing the processing, for doing machine learning, you need data, and for the data to be processed, you will use either distributed computing or parallel computing, or sometimes you cannot afford either of them, then you'll have to continue using this. All right, now let's come back to the machine learning. The most important part in machine learning is that there are two phases. Just like we have our phases that in first phase we are studying, in the second phase we are applying. Similarly, of course, and learning is continuous for us as well as machines. But in general, when you think about it, it's got two phases. First phase is where you have the data. You have the data fed to the algorithm, and algorithm is coming up with the model. So algorithm is looking at the data and is coming up with the model. And to do that, you need to have data, and you need to have really, really good computers. And once we are done with the model, in the second phase, we call that inference phase. The first one is called training phase, and second one is called inference phase. In inference phase, what we do is we basically take the model that was prepared in the training phase, and do the inference. Okay, so this is how you can visualize it. This process consumes lots of resources, and this process doesn't consume that much resources, but the turnaround time has to be really, really fast, because when the user's request is coming up and you have to give the recommendations, you have to basically give it really, really fast. Okay, so which of these are going to be slow? The training phase or inference phase? Which of these phases are going to be slow? Anybody? Yes. That's right. The training phase is going to be slow. Well, inference phase would be faster, right? It takes like a year to teach a kid 1, 2, 3, 4, right? And if you ask a kid after the kid has learned, it's very quick to recall, right? So similarly here, the training takes long time while inference takes less time. Now, I want to again give you an idea that earlier, if we have to solve a problem, what we used to do is we will study the problem, create our own rules, we create the code, if else conditions and all that, and then we evaluate that if else conditions on test data. And if it's working well, we launch. Otherwise, we go back to analyzing. This was traditional. This is something new in the sense that we study the problem, we take the data, we feed it to the ML algorithm, and let this ML algorithm come up with the rules. Okay, so instead of we coming up with the rules, this ML algorithm will come up with the rules, and then we will launch it, right? So this new age, the one that we're talking about using machine learning, what are the advantages of the machine learning approach? Anybody? This approach? So here we are writing rules. Here the machine is figuring out rules. And you can imagine for this flow for, let's say, spam filter. If we are building a spam filter, we are training the machine to look at each email, and we already have labeled the data saying that this is spam and this is not a spam, right? So we are doing that. So my question to all is, using what are the advantages over the traditional approach we have for the machine learning approach? Yes, we might miss lots of rules, but machines don't. That's a good point. Yes, and yes, so there are lots of things that we may not know about data. Okay, therefore, in such cases, machines have known to perform really well. Okay, so as of today, the spam filter in Gmail has figured out its own rules and all kinds of rules around which one is a spam, which one is not a spam. All right, so the other thing, okay. All right, so like, for example, I'll give you one more example. Let's say you came up with a rule that if an email has free in subject line, okay, that's a spam. So we wrote this rule, okay, and we also wrote similar rules, like if it is something to do with sales, something to do with this, something to do with that, then it's a spam. Now, these rules will become such a big mess that lots of engineers will have to manage those. Okay, lots of engineers will have to manage those rules. Okay, now this is exactly why machine learning based models are way better, because the machines are able to do better job at managing these rules, optimizing these rules, and so on. Okay, similarly, earlier people were writing the manual rules to recognize voice, converting the voice into text. Okay, that if the frequency is this much, then it's this letter or this syllable. If this is this much, then it's this label, and like that. And that did not turn out to be great. Okay, in today's time, the voice recognition system basically has been trained on lots of voice samples, and it has figured out a correlation between voice and the text. And given a voice, it will give text. So the rules are something, as of today, are written by mostly computers instead of you writing rules. Okay, so the another question that people have in mind is, what exactly is cloud? Okay, so cloud is nothing but a computer system at someone else's place. Okay, and this computer system is accessible and available. Okay, as in the way clouds are visible to everybody, multiple people, and when it rains, it goes to everywhere in that area. Similarly, when something is on the cloud, it is accessible and available to all, right? So that's why it's called cloud. And but in very simple terms, it's a computer at someone else's premises, which is accessible and available. There are many cloud providers, such as Microsoft. The top three are Microsoft Azure, Google Cloud Platform, and AWS. I cannot comment on the thing that what should you prefer or what should you not prefer. I'll give you a good answer to that. Okay, so there are many cloud providers like Azure and Google and Amazon. Okay, so in today's time, setting up or creating your own cloud platform is not really useful. Okay, the reason is the reason is that the reason is that if you if you set up your own computers in a network or in a cloud, it takes lots of capital investment, and it becomes difficult to manage it, because you have to take care of the power, you have to take care of the backup, you have to you have to take care of the automation in case one hard disk goes down, you have to move the application, the system to another machine, and so on. And therefore the cloud-based computing has made the life easier for everybody. Okay, I don't think people are hosting mission critical applications on their premise anymore. Instead, they are moving to the cloud. All right, so okay, so out of these phases, which one do you think is good for the the training phase and inference phase? Which one is good candidate to be put on the cloud? The downside of the cloud is it is costly, and it is costly because you have to pay as per the service provider wants, right? The second problem with the cloud is that you will have to transfer your personal data or data which is sensitive to outside your premises, outside your own data center. Okay, therefore lots of companies do not want to go for a cloud. But the advantage of going to the cloud is that your hardware management overheads go really low. And these cloud services providers have started providing lots of AI services, lots of machine learning services, and so on. Okay, so quick question to all of you. Which one is a good candidate for putting it on the cloud? The training phase or inference phase? Yes, training phase or inference phase. That's right, Rohit. It is the inference phase that is a better candidate for moving to cloud. Why? Because when you have the when the so let me so the in the machine learning model, there are two phases. One is training, other is inference, right? The inference phase, which is usually on the cloud, because inference phase, you want it to be available. Like when your user has requested, if you think about Amazon, if you open a website and it's going to give me recommendations on the product, right? These recommendations to the product should be accessible by the user and should be spontaneous, right? And therefore, the inference phase is okay to be on the cloud, and this is the right thing to do. But the training phase, where you have terabytes of data and you have hundreds of machines concurrently churning this data in order to give you recommendation or create a model. In that case, if you take the cloud services and you run 100 computers for a couple of months to do the training, you are going to have really, really huge data center costs. Okay, therefore, usually what people do is training phase and other less critical phases you usually do on your own GPU machines or your own parallel computing or high processor machines which are there on the premise, and the mission critical computing is usually done on the cloud. So this phase, the inference phase, is a better candidate for the cloud, while the training phase is usually on premise. And this transfer from here to the cloud, that is something that you have to do, right? Now, there are these cloud providers have become really, really good, really, really useful. So Google Cloud Platform, other than providing a way to run your models or load your models and so on using TensorFlow or cloud machine learning, it has also started providing things like Vision API. Vision API for recognizing faces, then Speech API, the Jobs API, Cloud Jobs API, and Google Translate API, Natural Language Processing API, and the Video API. So basically, over a period of time, most of the cloud providers are coming up with these machine learning services. Okay. Similarly, we have Microsoft Azure. They have also started providing all sorts of machine learning APIs and tools. Similarly, AWS also has come up with lots of ML infrastructure and services that give you the intelligence, right? Now, a question that lots of people ask. Okay, somebody has raised a hand. Okay, please go ahead. Yes, go ahead. Kunal, you had a question for me? Okay. All right, or maybe by mistake, he has raised a hand. All right, feel free to ask questions. I want to make it more interactive. Do you have this question in mind that which programming language should I learn? Yes, Rohit, go ahead. Either Q&A window. Do you guys see Q&A window? Okay, so this is the most common question that people ask me. Okay, let me just see if I can walk you through this. Okay, let me, can you see my screen? So let me break it down for you. So there could be a question like, which programming language is the best, right? Which is a good platform for doing the AI and stuff, right? Which best cloud you have, right? Which cloud is the best? Okay, these kind of questions you will have in mind, and these are very valid questions. And the reason why we have these, these questions are very valid question, that which programming language I learn, right? And it's a valid question because it takes time to learn anything, right? So the question is, what exactly should I do? Okay, here is my thumb rule to all of you. Okay, there are two extremes. One is being too philosophical, too generic, right? like we only talk about, say, high level things that, okay, I think that Excel is a programming language. Okay, so this is like being too generic, too theoretical, and do not have a real ability to build things. Okay, that's the one extreme. You don't want to be on that extreme. Okay, on the other, if you are like a philosopher who has done a lot of hands-on engineering in first, and then as he grew, then they have the right to be very generic and be very theoretical. Okay, but if you are a freshman or a engineer, okay, it is not good for you to be too generic. Okay, and here the other extreme is we become too specific. Okay, okay, we become too specific in the sense, okay, I can only do like coding using AWS infrastructure. I cannot do anything else. Okay, or you say that, okay, I only learned Java, and the Java is the only platform, the language Java is the only language I'm going to use, right? So that's too specific. Okay, and that's also disastrous. That the reason is, in a software there are multiple languages that are needed. Similarly, in a company you might move between projects to projects, correct? Similarly, in your career you will move from one company to another. Therefore, being specific to a programming language, specific to a platform, specific to a cloud environment is not going to help you in any way. Okay, so keep yourself in a perfect balance. Be hands-on, but be hands-on on generic technologies. Okay, generic technology. And the beauty is this, in the world that we are living in right now, the beauty is this, that almost every technology, almost every company has moved to the open source systems. Okay, like for example, almost every model that is there in the production, whether Google is using internally or anybody, all of those are public. Okay, so the algorithms are public, the models are public, and right, what does it mean by models? The model in this case, if you go back here, so many people keep on training these models and keep on making it available for you. Okay, so you can take a look at, say model zoo. Okay, so the model zoo looks like this. Okay, so you have somebody else has done the training for you, like this one. When you show it your show it a photo of a person, it can tell where are the joints in the body. Okay, so 130 joints or key points it gives you. Okay, so that's called open pose. Similarly, we have Mascar CNN, PyTorch, and so on. So take a look at these models. These models are essentially pre-trained model by somebody else that you can use. All right, so the point I was trying to make here is that which programming language is good for you, which cloud platform, and so on. So the answer is, don't be too specific. Don't be too specific. Maintain a perfect balance. Maintain a perfect balance. You should be generic enough, right? So instead of being specific to Python, or you should not memorize. You should not memorize a particular library or functions, right? And you should know how to translate a problem into code. That's the definition of learning programming. Okay, you do not learn Python, you learn programming. Okay, there are many people who spent a lot of time in just memorizing all functions in different libraries, which is not worth it, because as you move between platform, between systems, those functions and libraries will change. right? And therefore, it does not make any sense to focus on a particular API or memorizing. Google is your friend. You can just look up at Google and find out what are the functions, or every language provides you documentation on how to how to look up for the documentation. You can just use those methods to look up for the documentation. Okay, so you don't need to really memorize anything much. You just have to focus more about keeping yourself generic enough and still hands-on. Okay, and to make sure that you learn it this way, we have created projects and so on. Okay, so basically this is where you want to be, neither too generic nor too specific. Okay, so the next thing I was saying is that which programming language let me answer this question. The answer is any programming language is good. Okay, and good. Just that you should focus on the more popular one. Probably Python would be a good choice, easy to learn and so on. But any programming language is fine. Okay, just focus on learning how to translate a problem into code. Okay, so the more focus should be how would you understand what is recursion, right? What is recursion, and how do you solve a complex problem using recursion, and how do you create objects and so on, and create like structure your code and understand the data structures and algorithm. So when you are talking about learning programming language, make sure that you learn these parts. So okay, etc. Okay, this has no limit to it, so you just have to just go through the basic fundamentals and that should be good. Now the next thing that people ask is which ML platform is good for AI? Is it PyTorch, or it should be, say, TensorFlow? Okay, okay, right? Now, the beauty of the any machine learning platform is that, all of them have same functions. Okay? So focus on learning the fundamentals of machine learning. Okay, machine learning. And you will find a lot of content on our website to learn this part. So you can take a look at our courses. The next part that people ask, that if there is a cloud, what is it that I should learn? What should I learn basically? Okay, when people, right? Because if you, let's say you're working with AWS, and essentially you may not learn many things because they are already doing all the things, right? But there are many very important things that you need to learn. You need to know how to deal with an operating system like Linux, because if everything is a remote, you're going to use mostly the Linux commands, right? The second thing that you got to learn is, when you're dealing with cloud, is the networking part. Okay, the next thing that you are going to learn as part of this is you should focus that part. So if you are going to understand cloud, the other systems like Docker, etc. Okay, so anything that is generally applicable in all these systems, that is something that you should make sure you learn. Okay, and any cloud will look very simple to you if you know the fundamentals. Okay, if you know the fundamentals, every cloud will look like, okay, it's just same thing. Okay, and tomorrow, in case in case your company decides not to go with a particular cloud platform, you can create your own. All right, so this is what it is. All right, shall we take a 10 minutes break? I think many of you have. Okay, let's take a 10 minutes break. Back by 3:45. All right, so I'm back. All right, everyone, so I'm back. Everyone, shall we start? Hi, everyone. I'm really happy that most of you have been sticking around. Great to have you here. Okay. You guys really don't have a question? Is it like I'm all right? So feel free to ask questions, please. Okay. There's no such thing called good question, bad question. Whatever is coming in your head or in mind, just ask, please. So there was long ago, there was a question. Yes, there's a question from somebody on YouTube. Please try to discuss applied aspects of AI in agriculture, operational and resource management. And okay, so the idea is that one, I'm not really an expert at agricultural, operational and resource management, honestly. Um, Probably if you understand the AI, or if you are an expert, if you are an expert in a particular field, if you understand what is it that machine learning can achieve, right, then you will be able to come up with better applications. Okay. And the title of this talk is more about AI and cloud computing. All right. So one of the important things to do is that understand what is that is achievable using AI. So understanding that if we have labeled data, we can achieve almost everything, right? If we have labeled data. And if we have that understanding, then and we have understanding of a domain, we will be able to come up with great solution by ourselves. Perfect. Now moving ahead. Okay. Please feel free to ask questions and I would love to answer your questions. Okay. So one of the things that I was discussing is that always when you're planning your career in anything, okay, be specific, but not too specific. Okay. Focus on analytical way of solving problems rather than memorization way of solving problems. Okay. That's how it is. And that's how you should always look at, right? So you do not have to memorize what functions to use in order to read or do certain things. You can just look at, if you're not, see, the learning in general starts with memorization, but that's not the end of it. In order to unmemorize, you will have to learn the alternatives. And once you learn the alternatives, you will understand the generalization parts of it. Okay, so you have to have either the learning that you should have is, it should be generalizable. Okay, because companies change, their products change, you also move between companies, or the companies also move you between the teams and so on and so forth. Therefore, it is better to be generalist, because if you are a little generalist, then going specific is very easy. But if you are not, if you are too specific already, you cannot go to the other extremes. Okay, so the most important part is to keep this in mind. Okay, to keep this in mind always. So one of the things that we have done is we've created these nice guided projects. I want to show you these guided projects. Okay, I want to show you these. Okay, here. Yeah, so I want to show you, if you go to cloudxlab.com and click on explore courses, okay, there you will find these lots of things here. You just pick the guided project here. you'll see lots of projects are there, and these are guided in the sense that there's a guidance available. Okay, so if you are planning to learn anything, okay, you start with guided project. It teaches you a number of things. It teaches you, just pick any of these, start doing it, and that's about it. Okay, the other way is you should take up a course in order to learn, say, machine learning or any of these technologies. So you should take up a course at CloudXLab. So if you are looking for a full-fledged MLOps course or DevOps course, you should just pick any of these. Okay, and there is machine learning specialization that includes almost everything. Okay. All right, the other important part, okay, so let me just start with the sequence of things now. So the first thing that you need to learn is probably the programming language. If you are comfortable with any programming language, you will be able to pick up machine learning easily. Now, in order to learn machine learning, one of the things that I would strongly recommend is either you take the courses or you come to this page, click on, say, guided project, and search for say, machine learning here. Okay, so you will see these machine learning projects. These are very important projects. So take up, let's say, this one. Okay, this one. It has got around 15 assessments in it. So you take a look at this one, and this will help you understand how to do machine learning. Okay, you may not understand as part of this project exactly how algorithm works, but you will understand the process of creating the machine learning model. Okay, the process of creating the machine learning model. So I would strongly recommend you to go through this one in order to learn the machine learning. Okay. The other thing is that out of all the things that are there, like Python, scikit-learn, and TensorFlow, that seems to be a good combination. But again, when it comes to, some of you might be thinking that why with TensorFlow, why not PyTorch, why with Python, why not with some other language, right? The truth is that the underlying principles of all the algorithms in every programming language and in every platform, the underlying principles are identical. I'm using the word identical. Okay, so it is okay to start with, if I mean, it is, if you learn something using Python, scikit-learn, and TensorFlow, you will also learn using any other programming language very quickly, or any other cloud providers very quickly. Okay, so that's the first thing. If you are planning to get into AI and MLOps, we call them MLOps. So MLOps is machine learning, and DevOps combined together is MLOps. So if you are trying to get into MLOps, the first thing that you should do is just go through like machine learning end-to-end project. You should understand the process of machine learning model creation. Okay, and that's pretty simple and short. Right now, once you have understood how does the flow of creating a model works, you will have the thought clarity into creating the model. Now, once you have done creation of a model, now using this model will require decent amount of engineering, and that is something that I want to focus more as part of this discussion today. Okay. The first one is, let's say there is a model trained by somebody. Okay, there is a model trained by somebody, and you would like to deploy that model. Okay, so or you yourself train that model. Okay, so what you'll do is, first of all, you will build it like proof of concept. Like, you will load it using the programming language, and you will try to explore it. Okay, so take a look at this particular project. I've actually, these are all free and open for everybody. So this is one project whereby it makes you do, load a pre-trained model and do the inference. Okay. Using this, you will learn how to load the pre-trained model and do the inference. Okay. Now, once you have done that, let me make a screen area a little bigger so that you can. Okay. All right. Now I think this is better. So this is, yeah. And I will also hide. Okay. So, all right. Okay, let me just see if I can hide it. Basically, I would just want to. Okay, never mind. So let it be like this. Perfect. So, okay. So basically, this is the way you start. You take a pre-trained model and load it using your code in Python or any other language. Okay, the Python and any other language. And this, after you have gone the understanding of this one, you will realize, so as part of this particular project, what you learn is how to use a pre-trained model to figure out whether something, what is the object inside that image. Okay, what is there inside that image? What is the, so identifying object is the thing that it teaches. Okay, using a pre-trained model. Now, using that pre-trained model, you should, right? So using the pre-trained model, you should start with right here. And once you have become comfortable, you will get an idea that fine, I am able to run this model using the console and the script. Okay. Now the second step is, or also let me also put some values to it. So the next thing that you need to know is, if you are trying to do this particular exercise, you need to know a bit of Linux and Python, and you can just, if you know how to do your own models, then your thought clarity on models will be very clear. Okay. Now, the next step is taking that program that was running in console and running it in the browser or converting it into the web app. Okay, that's what you will find this here. You will find this particular project here. So in this project, what you would do is take the model, take this particular program and convert it into a web application. Web application requires web server. It requires the understanding of when you are building this, the web application, you would need to understand a web application framework such as Node.js, Django, and other Flask. Okay. Okay. And you should have an understanding of HTTP. You should know HTML, CSS, and JavaScript. So those are the additional things that would help you understand a web application. So this is a full-fledged web application using which you will, when you do this project, you will get a full-fledged understanding on how to take a AI model and put it in production. Okay. The next step is, so this is like the evolution of an AI app. So first you created it like a desktop script where you run it and it displays you that this is what it is there inside the image. And you took it to a web app and then you kept on moving it to the next level. So the next one is making it efficient and better. Okay, this is where your understanding on new things come into play. Okay, so all right, So this is where your understanding of various services come into play. Okay, so this one, the one that you have here, okay, let me just duplicate it. Okay, let me remove this. All right, so here what you do is usually what you learn in your colleges or somewhere in the open world is that we created web app and that's it. We created a website, we are all happy. But that's not what happens in larger organizations or anywhere. What you do is you break this big web app from monolith. Monolith means created with single stone. Okay, so you break a web app into small programs. Similarly, as part of this particular project, you will learn how to take one monolithic system and break it into parts such that it is very much manageable and it is extremely fast. Okay, and this is way better way of doing things. Like the Amazon detail base accesses around 100 services to render the content. Okay, so hundreds of services are running in order to give you the complete website. There is no single machine serving the entire website. There are parts which are being redirected to different servers, and they are assembling it and then giving you the results. So similarly, when you're building any production ready or production system, you always build these smaller, very specific systems, and we call them microservices. Okay, and this is extremely important. So you take the big product, cut it into pieces, and make it independent. And that's how you manage large scale systems. So this particular project is again really helpful. And I can assure you that if you finish this part, your half of the engineering is done. Okay. The next comes as taking these services to the cloud. How would you take these services to the cloud? And this is where the understanding of Docker comes into place. Okay, so I want to explain to you this part. So what happens is when there is a website that you built, it is working on your computer, and when you send it to somewhere, it may not work. And I remember my early days of college days, right? When I competed in some college fest, I designed a small website on my desktop. And when I went for the presentation, it did not work. I copied it into floppy and took it there. It did not work. So then what we did was, me and my teammate, I went to the hostel, picked up my big monitor, that CVT monitor, and the CPU, and the CVT or UPS, what you call it, and then took it to the presentation room. So that was, the day. And I so well remember, because this was the height of unprofessionalism. Okay. And in real life, in the production environment, you can't afford to do that. If you go to a customer site and it's not working, and right, it is useless. Your piece of software is absolutely useless. And this is exactly why people came up with these virtualized environment. And those are like wonderful. We call them containers. Containers are amazing because basically write the instructions on what all to install, and it will just work fine. And if you have like multi-teams environment, like in another country or another state, people are sitting and testing your application. And in those cases, if you are not following a standard practice, that's not right, right? So you remember the software installation flow, and you must have gone through it. So you download the installer, you run the installer, error. If error occurs, you troubleshoot and fix the error, and you run the installer, another error, and you get into this loop. How many of you have faced these issues with dealing with Windows installation, right? So this is like crazy thing that we have done. So this is where the ideas of virtualization come into play. Okay, so on top of the hardware, you install an operating system like Linux or something. On the Linux, you install Docker. Inside Docker, there are many other applications that are launched. Okay, so many parallel worlds or many parallel universes can exist on top of Docker. Each of these apps could be installing their own dependencies. One is depending on Python 2, other depending on Python 3, this one depending on Flask version of 6, this one depending on Flask version of 5, and so on and so forth. And they have like full kind of dependency conflict. So creating an isolation is the most important part here. Similarly, this guy could be creating a folder at the same place as this guy is creating. And if they are on the same system, they will mess up each other's folder structure. And this is exactly the Docker comes. It gives them their own small world where they stay happy here. Okay. So earlier, the Windows was like combined family. Everybody was using the same washroom, same kitchen, same everything. And then there were conflicts and there were fights. Right? Those who are from Indian context, they can understand this part. But in case of Docker, what they did was that each one is living in their own independent house in the same house. On the same computer, there are different computers inside. So that's the beauty of it. And those who are inclined to know more about virtualization, you should take a look at what is hypervisor, take a look at what exactly is VMware virtual machine, and so on. VMware virtual machine is like, you know, on a single OS, there could be multiple different OSs altogether, and they could have more Docker containers. So the Docker container is something very important to know. So you define your image, you create your image, and you ship the image. And then on the production environment, this gets quickly installed and starts running. And you are with 100% peace of mind that if this is running on my computer, it will run on anywhere in the world. So the developer builds the image and sends it and packages it. And then the other people, the users or the testers or other people, they basically just run it and it works. And that solves a lot of problems. This is exactly where Dockerization comes into play. So whatever services or software that you created, you package them as Docker. So you should take a look at this particular exercise or a project whereby we've tried to convert this into Docker images. Okay. The next one is scaling and orchestration. Scaling and orchestration is another idea after Docker. So you created these images. One of them could be running 100 copies of it because there are so many overload of that particular service, and then other service could be running lesser, and so on and so forth. So you can basically orchestrate them, scale them independently. And this changes the way we look at the software. The software today is not same as what it was 30 years ago. Software today has many moving pieces. And if you're not aware about these ideas, you won't be able to build a scalable system. You won't be able to build a production-ready system. You may be. So for this to work, you need to have fair amount of understanding of Docker and so on. Now, the beauty about it is if you learn these containerization ideas, or you learn the orchestration using Kubernetes and others, what happens is that these things are common across all cloud providers. So you don't have to become specific to AWS, GCP, and so on. Your system, you design the orchestration, and that will work everywhere, even on your own cloud. So this is essentially the life cycle, or you can say the evolution of an AI application. We started with a single command line, the way it used to be in long days. Then we made it a web app. Then we broke it down into multiple services. Then we containerized each of the services. And then we took the containers, deployed it on top of the Kubernetes. So take a look at these projects. They are really nice. I'll be sharing this presentation with all of you so that you can click the link and access it. Okay. All right. So yeah, feel free to ask questions, please. Let me know if you have any questions for me. And in the meantime, you must take a look at say how to build this. Okay. So if you go here, so this one is the way you basically launch one of the things. Okay. And then here is the, no, not this one, next to this one. Okay. So this one. And then this one. Okay. So from here, it's from right to left. Okay, so we start from the right, and before that I was suggesting this one. Okay, let me go up, up here. Okay, so this is your sequence of learning. Okay, first of all, you went through end-to-end machine learning project, understood what it means by models and this and that. Once you are comfortable with it, then you picked up a traditional existing model called ImageNet for face recognition or object recognition. And you did the object recognition here. And then you took this object recognition to convert it into a web application so that anybody on the web can use your service. And once you have done that, then you made it further efficient because this one was taking around 16 seconds to do inference. So you build this system so that we brought it down to 0.3 seconds from 16 seconds here in this particular example. And once we have done that, we took those services to convert it into Dockerized image. And then we basically, here is another example whereby if you have your cloud and you want to deploy the Docker containers, you can deploy it here. So that's the main idea behind learning the AI and cloud together. Okay, so the most important part is learn the machine learning and AI in basics. So you start here, or you can just take up any of these courses, and this will help you. Okay, so I would strongly recommend to go for either this or this. Okay, and then, all right. So this is about the, okay, so this is the entire flow. Okay, so feel free to ask any questions. We still have 10-15 minutes for questions. So we have 10 minutes for more questions. So you can ask questions and feel free to, even if you are confused at certain point of time, do not worry. I'll take care of the question. So always ask lots of questions. You don't have any question either?
Hello, sir.
Yeah, hi.
Yes, sir. I'm Rohit Pal. I just asked two of the questions in Q&A.
Okay.
So if you could, I have few more questions, but if you could,
okay. Let me just check.
Could discuss on that.
Oh, there is only one question that I can see, which I answered earlier. What will be the best way to learn AI basics and its important topics? Yes. So my understanding is that to learn the AI basics, okay, and to learn the basics of AI, what I would suggest is that you start with this curriculum is actually nice. Okay, I'll just walk you through this curriculum. Okay, this curriculum is something nice. You should take a look at this curriculum. Okay, the way it goes on is in a very or you can just click on audit course and you will get a fair bit of idea from there. Okay, so you can click on learning path. Okay, so here, so one is like fundamentals. Everybody needs to know Linux or Python or any programming language. Then a bit of overview of linear algebra, then NumPy, and then a bit of statistics and so on. Okay, these are very simple things for you because most of you are engineers and you will just get it immediately. Okay, so then there is like the overview of what is AI, what is not AI, and then kinds of this one. This will basically be very quick for you. Now, this is something that I put a lots of focus. So always, this is something that you should never miss. You can skip the entire machine learning course, but do not miss this project. And this project is also available as part of like the free projects on CloudXLab. Okay, so make sure that you do this, and make sure you do this. These two projects, this one is also project oriented, this one is also. So, and rest of it is about how algorithms work, how to improve their performance. And as a engineers like who are fresh from the college, you may skip these parts, but if you are interested, it actually helps a lot. Lots of people have told me that this has helped in their career, right? And if you, and I would also suggest that in case you are, in today's time, people have started expecting that the engineers fresh from college should also know neural networks. So at least finish this and this, these two chapters. Okay. And if you, I mean, what was that? Yeah, this particular topic would teach you the entire understanding of the neural networks. Okay, so this one is essentially something that would help you a lot in understanding it, and in understanding deep neural networks. So this is kind of a general flow. No matter what you do, no matter whether you take the course from us or someone else, I mean, follow this curriculum. Okay.
Okay, sir.
Follow this curriculum, and this will help you in the career. Let me see if I.
So I had this another question.
Okay.
So the thing was, few days ago, I'm an electronics and telecom student, and I have chosen artificial intelligence as a specialization. So
Okay.
we are doing that course from NPTEL, and there are a few professors who are teaching that, but
Okay.
they started with essential mathematics of machine learning. So they picked the topic of linear algebra. In start, I didn't know why specifically they were teaching that, but the topic they started with vector space and basis and Albion group and all, which I haven't studied in my past curriculum or academics.
Okay.
So I started searching on Google and YouTube, and I got to know that linear algebra, like those multidimensional mathematics, helps to access machine learning better way. So
Yeah.
can you tell more about how mathematics can be, how mathematics, as you just few minutes ago explained that we can proof concept that you showed, and then web app, and then Docker, that microservice architecture, and then Docker.
Yeah.
So
Yeah.
in those whole process, I didn't see mathematics. So
Yeah.
how exactly mathematics is involved, and how, which is the better way to learn mathematics related to that linear
Yeah.
algebra and all?
Yeah. So basically, internally, this algorithm is using the design of an algorithm is around the maths, correct? So
Okay.
the algorithm, like for example, if let's say your salary on first year was say 5 lakh, in salary in second year was say 7 lakh, and what will be the salary? This was your salary in first year. Second year, what will be your salary in third year? Anybody?
I guess it's 9.
9, right?
9.
So how did you guess it?
So the 5, 7, and then the sequence.
Yeah. So this is essentially what a linear regression is in simple words. So we're trying to fit a straight line into it, though it doesn't look like a straight line. Ouch. Let me see if I can draw it. Okay, let me see. Okay, so this is how your machine learning looks like. Okay, so now if you see basically how the algorithm works, understanding that part, you require the linear algebra. But my suggestion to all of you would be that don't get hung up on that. Okay, it's so common to just get lost in the algebra and do not proceed. Okay, the linear algebra is essentially, like this. You have a list of numbers and you have to double all of them, right? So one way is just you write a for loop and you double them, correct? Like write a for loop, create. right? The other way is using the linear algebra, we multiply a vector with two. Okay, so the most important part, instead of just get lost into this linear algebra, my suggestion will be that have the overview, have the understanding, but one of the key things that most of the people miss out is they basically do not know how to build a machine learning project even after finishing the entire machine learning course. That's why what I did was I inverted it in the sense that I start with a project. Okay, so my suggestion will be that let the theory go on, but start with the project. Okay, that way you will remain interested that you are doing something. Okay, and the other big part you will understand is that learning the machine learning is essentially a fairly big idea. Okay, it is okay to just have a hunch how algorithm works. The way I explained that, okay, we are predicting something and the algorithm is drawing a line, right? This hunch is good enough. Okay. Similarly, if you want to really learn, how exactly the neural network works. So I created this simple tutorial that is really popular. Okay. Just try to go through it. Okay. So if you are into understanding of algorithm, you should take a look at this one. Okay. Otherwise, what I found is that most of the engineers are lost into studying statistics, then studying linear algebra, and they never get back from there. They lose their interest and they never get back there. Okay. So to understand what's going in the algorithm, it is important that you learn a bit of algebra, but I would say that just take a look at this one. This one teaches you the hardest concept of AI or machine learning, that is called backpropagation. Okay, so backpropagation is the one of the most important ideas in today's time. Okay, so learning the what's going in the algorithm is important, is very important. But trust me, more important is to understand the practicalities of it. Okay, 90% of time of, first is you will rarely, okay, if you are in a IT software company and you are a data scientist, 90% chances are that you will be busy in deploying a model rather than building your own model. Okay. Second, if you're building your own model, your main time will go in data cleaning and end-to-end projects rather than inventing a new algorithm or understanding the internals of the algorithm. Okay. Therefore, learning the end-to-end project weighs more or is way more important than knowing exact mechanics of how an algorithm is working. Okay. It's good to know, good to have hunch, but most important part is to know how to use an algorithm, to know how to optimize things. Okay. So the most important part is, while getting into each pieces is extremely important, but you should know how to tie it together. Okay. If you are not able to tie it together, then you won't be able to really build anything and you will also lose interest. Okay.
Okay, sir. So mathematics is important, but we should just have overview and move on with project.
Yes. So
Okay.
that's how I always recommend everybody that see, the thing is that if you do not see anything to build, like this talk is usually not that useful or interactive because it's like one way. Okay, unless you do by yourself and you keep on tinkering into it, you won't get the joy of doing things. It's like I take you, let's say you come to me for tennis classes and I'm teaching you tennis. And what I do is I put you in a room and I do not let you play tennis for a month. All I tell you that this is racket, there are 20 kinds of rackets, and this is how you do the wiring of the racket, and so on and so forth. Okay. So, right. Another popular analogy,
Yes, sir.
is that in order to make music, you need to know how to play guitar, right? Not how to make guitar. Okay. In order to make guitar, you need maths, you need like entire carpentry and everything. Okay. Similarly here, in order to do machine learning, you necessarily do not have to create your own algorithm. Creating algorithm and creating model are two different things. Okay. So creating algorithm, you should know what is going inside it. Fine. You should know like basics of it. Even if you do not know exactly this process, you should know like there is a data has to be in this format. Data has to be, if there are text in the data, what am I supposed to do? If there are some columns missing, some rows missing, what is going on there? You should know that. And that's exactly what is covered in the end-to-end project. Okay, what's going inside algorithm is covered here. Okay, what's going inside the process is covered in end-to-end project, and what's going in the inference part is here, the one that I was showing you, those 5 steps. Okay, the last leg of it. Okay, so this. Okay, so this is the entire of these 5 steps are about inference. Okay, so the machine learning and computer science or computer engineering are way more overlapping, and yet we study them in isolation. And okay, do I make sense? Was I able to?
Yes, sir. Yes, sir. Perfectly. So just a last question, and I'm sorry to ask two back-to-back questions.
No, these are good. These questions are good. They will be useful for all the people who are attending. Yeah. If other people.
Yes, sir. The last question was that where do you see the electronics engineer involved in AI, specifically in AI?
All my classmates who are in electronics, they ended up doing being a computer engineer. The topper of my class, who is in 2002, who is, because at my time the electronics were the #1 branch, computer science was second, right? So most of the engineers took that, and everybody is doing machine learning research. Yesterday himself, the electronics engineer, the topper of that, he published 2 papers recently, and he has multiple patents. So many people are, almost every engineering, the way computers ate up all engineering, every engineering, whether electronics, whether mechanical, even my friends who went to cement factory, they ended up using machine learning. Okay, not machine learning, they ended up using computing, using the entire maths of it. That time machine learning wasn't there, wasn't that popular. So the point I'm trying to make is that as you grow in the hierarchy in an organization, everything is a machine learning. If one of my colleague, who is Praveen, he has built really wonderful things in electronics. And if you ask him, he'll tell you that he has multiple patents in machine learning and these and electronics overlapping together. So his point was that starting from manufacturing to synthesis, everything has become computerized, and therefore you should be really good with computing when you are dealing with electronics. Okay, computing in all kinds, right? Whether it's machine learning and so on, like how do you place the chips at minimum number of like minimum area, and how do you arrange that? There are lots of evolution happening there, and the fabrication itself is impacted. And in industry, it becomes imperative that when you join an electronics company, you are most likely going to work on the electronics. So one of the professors who works at the accelerators, he's teaching machine learning, and underneath, to optimize various components, various parts, understand the graph, or understand the behavior of various components with respect to the power. It's all done using machine learning.
Okay, sir. Thank you very much, sir. Thank you for your time.
All right. I hope I made sense. I have a couple of more minutes. A question is, which country is good for future in cloud computing and AI? Okay. I do not know this, okay, to be honest, but the whole world is your playground. If you are good with computing, you can pick up job anywhere, because thanks to COVID, There are so many companies who are hiring from India, and people are working from all over the world, all over the world. Okay, like I saw lots of recruiters hiring from, the people who are learning at my platform. So they keep on hiring, and so the whole world is a playground. And the beauty about it is that those who are wondering like what it is, so Australia, Canada, um, Australia, Canada, Singapore, and Germany, and UK, and Dubai. Almost all the prime countries have come up with something called golden visa. And then if you have a good certificate in the cutting edge technologies, they usually offer this golden visa to them. But it may not matter to you. It may matter to the people who are in the elder age bracket, whose points are not matching for the visa. Okay, so the idea is that it is really helpful, and it opens doors everywhere. Okay, and country-wise, I can't. I am really not an expert on international politics. Okay, so a question is, what is the future of AI in cloud computing? AI in cloud computing is real. Okay, so real in the sense, all my friends who are working with top IT software companies, almost all of them are essentially working with any of these cloud, mm, you know, cloud providers, AWS, Google, or anybody. And they all are using either Google's models or Facebook's model, or their models, but they're all using AI in one form or another, whether it is for OCR, optical character recognition, or it is for as simple as voice recognition, or it is like understanding the sentiment of the voice and so on. There are so many use cases today in that, or something like NLP, natural language processing. Okay, so almost every industry, every vertical is impacted. Okay, so there's lots and lots of future, because specifically AI in cloud computing is something that is there already. It's not something that is future. It is there. It's a present. Okay. A question is, can you tell us about Databricks? Okay, good question. Good question. All right. So what exactly is Databricks, right? Databricks is a company that provides a platform called Spark. Okay. And what exactly is Spark? Spark makes your computation using multiple computers, distributed computing. Imagine you have 100 terabytes of data and you need to process it. Okay, so what you'll do is you will use Spark or some other similar distributed computing tool, and Spark will split the data to multiple machines, do the work for you, and give you the results. Like, for example, let's say you have 100 terabytes data and you're saying, give me the average revenue from the country, like from where the country is India. Okay, now this is going to go through each record, split it into parts, and ask all the computers to filter the data and then compute the average, right? So that kind of work that you do with Databricks. And wherever there is a big data, there is going to be big data, and you need to do the data analysis. Specifically, the data is not real time. In those cases, the Databricks platform or Hadoop or Spark or a similar system where you utilize thousands of computers to do the processing, in those cases, you will be using the Databricks platform or somebody else. All right, very good questions. And okay, a question from Surbi is that my research is based on solving ML ops by recently developed EAs, and my interest is more towards ML, from where I should start to learn things from basics level. I will be grateful to you. I'll actually request you to go through the flow, specifically what you see here. Okay, the projects specifically, these projects will change the way you look at most of the systems. Okay, so we have carefully designed this these projects so that you get the entire exposure of the process, and that will help you understand what exactly is MLOps. MLOps is essentially machine learning combined with ops. Just that the MLOps engineers, we do not expect them to know the underlying algorithm, but we expect them to know how to take something to production. Okay. All right, so wonderful. Thank you so much. And that's pretty much from my side. Come over to CloudXLab, take a look at things that we are doing there, and it would be helpful for you. Okay. All right. Yash, you want to say anything?
So Aman will be continuing.
Hey, Aman.
Okay, 1 second. I'm sending the feedback form link in the chat box. Please fill it.
Okay.
So just a short note about the feedback form. The feedback form will be used to generate the certificates. So all the participants are requested to fill it ASAP. Okay, so here, let's go ahead with a vote of thanks now. So good afternoon, everyone. This is Aman Rawat, Chairperson IEEE TCET. And it is a great honor to propose the vote of thanks on behalf of IEEE TCET committee to all those who have helped us in making this webinar such a resounding success. First of all, I would like to propose a hearty vote of thanks to our speaker, Mr. Sandeep Giri sir, for giving us an insightful session on cloud computing and AI. And the way you explained the topic was exemplary, sir. You gave us an overview of how computer can learn to play games, the various methods of approach to AI, which programming language to go with, which ML platform is preferable, which cloud platform is preferable, and the evolution of AI application, etc. Thank you so much, sir, for having this session so interactive and for answering all the questions and doubts with utmost honesty and candor. I would now like to express profound gratitude to our principal, Dr. B.K. Mishra, sir, for believing in us and giving us this opportunity to organize this event. I also wish to express my gratitude to our IEEE branch counselor, Dr. Lochan Jolly ma'am, for providing us with encouragement and support, and to our beloved HOD, Dr. Payal Saha ma'am, for her constant support. I am very grateful to Mr. Deepak S. Shetty, sir, and Mrs. Aradhana Manikar ma'am for their constant guidance, and the whole management team as well, who worked diligently to make this event a success. And as no event can become successful with just a single person, I would like to extend this vote of thanks to all the participants who have turned up in such great numbers. Thank you so much for investing your valuable time and attention. Once again, thank you for this webinar, sir. It was really, really great to have you here. And we would definitely love to collaborate with CloudXLab in the future as well. Thank you so much, sir.
Wonderful. Thank you, Aman, Yash, and your team. You guys have done good, wonderful job. And thanks to I mean it when I'm saying that you guys have done good job. Because these days I've been doing these talks once in a month or once in a week nowadays, actually. And I know what it means by organizing it. So you guys have done good job, and thanks to IEEE and all the audience who attended till the end, and your professors as well as your college. I'm really thankful and that you guys managed it pretty well. Thank you so much. Have a good day and stay connected.
Yes, sir. Thank you, sir.
Thanks again, sir. Thank you for the wonderful session, sir.
Once the feedback form is filled by the participants can start leaving the session.
All right, perfect. All right, I guess I'm not supposed to fill that one.
No, sir.
Okay, wonderful. Thank you so much. And my Himanshu is around. Himanshu, are you around? All right. So yeah. So you keep the you can end the YouTube live, but you keep this on. I have another meeting to go to, so I'll have to stop right away. I'll be exiting this. you take care of this. All right. Thank you,
So
everyone.
much, sir. Bye, sir.
Bye, sir.